Hi, SWK 351. This is James, and we're into chapter 11. We're doing t-tests for the means of different groups. And we're going to go through an example today, and it's a t-test with M&Ms. And we're going to enter the data into our spreadsheet today. And that will give me an opportunity to point out a couple of things that you'll have to be careful of with your statistical write-up. And then we're going to run our t-test in the same sort of way that the textbook talks about for chapter 11. So we'll go ahead and get started. And here's the context. We're talking about M&Ms, and there are two different factories that are producing M&Ms that get sold across the country. And these two different factories are designed to work exactly the same. They should be putting the same number of M&Ms on average in the bags. And so we're going to run a test to see if we took a sample from each of the factories, if those samples are going to tell us that the sample means really are the same, or if we have evidence to conclude that the mean number of M&Ms in the bags coming out of the two different factories is in fact different. And so now when we're writing our hypotheses, for the null hypothesis, we could say that the two means are equal. And for our research hypothesis, we could say that that the means are not the same. Or if suppose we had reason to believe that the first factory was actually putting more M&Ms in the bags than factory B, then in that case we might, or factory 2, we might say that our research hypothesis is that the mean for factory 1 is greater than the mean for factory 2. And so we're actually going to consider this as two different tests. One where it's a one-sided and one where it's a two-sided test. And we'll see what happens when we run the test. Okay, so we're going to enter in our data. Now, for factory 1, I'm just going to report the number of M&Ms for each bag. Okay, so we have one bag with 35, 37, 36, 28, 34, 33, and then 32, 30, 34, 35, 36, 37, 33, 35, 34, 36, 38, 31, 32, 35, 34, 36, and 33. Okay, that's our data for factory 1. Now, when you type the data in, be sure to verify that you've typed your data in correctly. If you type the wrong data in, you're going to run your test with an error, and that's not going to be helpful. So when you're doing your write-up, make sure that you verify that you type in the correct data. For factory 2, here is our data. 33, 35, 33, 37, 30, 31, 32, 35, 33, 30, 31, 33, 34, 31. Oops. You'll see that this is an error. That should be 30, 31, 33, 34, 31, 34, 33, 32, 32, 34, and that's our set for factory 2. Now remember, for your statistical write-up, we need to make a graphical representation. And you have to decide what you want to do for that representation. What I will do is I will show, actually, I'll show this real quick. We'll do a histogram. And I'm just going to show factory 1, but for your write-up, you'll have to show some sort of plot for, if you have 2 sets of data, you'd have to show a plot for each of them so you can compare your 2 different plots. So this is just a review from chapter 4. I'm waiting for this to come up here. Okay. And if I wanted to do a histogram, I already have the data selected, so if I click over here, it'll input that for me. Oh, I don't have my bin range yet. And labels, so I can just do this for my bin range. Let's just do this. So 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. And I'll put in a 27. Okay, so I can select this for my bin range. And then my output range, I'll just kind of set this over here. And I want a chart output for that histogram. I scroll over. There we go. I have a histogram of my data. So remember, we have to do that for the statistical write-up. When we're running these tests, it's good to have descriptive statistics and a chart of our data to kind of put everything put it all together and really paint a vibrant picture of what's going on with this data. Okay, so there's our histogram, and I'm going to back up here. And now we're going back to this t-test. Remember, our null hypothesis is that the means are the same. Now, the means of the number of M&Ms in the bags coming from the 2 factories are the same. And for the research hypothesis, let's just say the means are different. Now, I'm taking our critical p-value of, our critical value of 0.05 as our comparison for when we run the test. And now, if I have my my add-on for Analysis Tool Pack here, this is the one for Google Sheets. What I want to do is I'm going to do a t-test, and this is a 2 sample because they're coming from the 2 different factories. This is consistent with the t-test that we're running for chapter 11. Now I need to go to my data for variable 1, which is factory 1. Now notice that I do have the label selected as well. So there's variable 1. Here is variable 2. Notice that the sample sizes are not the same. They don't have to be, they can be in this case, but for this set of data, they're not. The hypothesized mean difference, we're doing 0 because our null hypothesis is that the means are the same. We are including the labels. Our alpha is our critical value, which is 0.05. And the output range is where I want to put the results, which we'll just put right there. And I'm going to click OK. And I'm just going to let that run. Variable ranges must have the same number of data points. Oh, I clicked on the wrong one. I'm sorry. We have a 2-sample assuming unequal variances. This is the t-test that we should be running. My apologies for that. And the reason why we're assuming unequal variances for this, we're just going to say that we don't have enough reason to believe that they would have the same variance because they're different factories. So there may be, since there's different factories, there's different machines going. So we're going to say we don't know for sure that they're going to have the same variance. So we're going to assume unequal variance. Again, our hypothesized mean difference is 0, and we are including the labels. And my output range is right here. Okay. Here's where we get our results. We have the means for the 2 factories and our variance. Now, the important thing that we need to see here is our p-value. Now, this is the p-value for the 1 tail, but our research hypothesis was a 2 tail. So we have this p-value of 0.0527. Now, since 0.0527 is bigger than our critical value that we chose as 0.05, well, we fail to reject the null hypothesis. That's our result. So here is a sample for running the t-test for 2 samples, assuming unequal variances. Now, if we had started this with the research hypothesis that the factory 1 has more M&Ms per bag on average than factory 2, if it was a 1-tail test, the p-value would have been 0.026, which is less than 0.05. And if that was the test we had run, we would have rejected the null hypothesis. And that kind of reflects this information. When we're running these tests, if we have reason to believe that we should run a one-sided test, then it's easier to reject the null hypothesis. But we should have good reason before we collect the data to have such a hypothesis. If we don't know, then we can run the 2-tail test. It's just more difficult to reject the null hypothesis. And that's our video for now.